Hello class, in this video I'll be introducing the vertex form of a quadratic function and showing you how to graph a quadratic function written in vertex form. Let's begin. A quadratic function is in vertex form if it is written as f of x is equal to a times the quantity x minus h squared plus k. The graph is a parabola whose axis of symmetry is x is equal to h and the vertex of hk. Okay, now I'm going to show you how to graph a quadratic function by identifying the 5 basic characteristics of its graph. Sketch the graph of the quadratic function f of x is equal to -1 times the quantity x plus 2 all squared plus 1. I'm going to start by finding the vertex. F of x can be rewritten as -1 times the quantity x minus -2 all squared plus 1. So the vertex is going to be -2, 1. And I'm going to place a coordinate on the grid at -2, 1. Part B, does the graph open up or open down? Well, all we need to do is look at the value of a. In this case, a is equal to -1, which is less than 0. This means the graph opens down. Part C, what is the equation of the axis of symmetry? The equation of the axis of symmetry is going to be the x-coordinate of the vertex. So in this case, x is equal to -2 is the equation of the axis of symmetry. Now I'm going to place a dashed vertical line through the vertex. This vertical line is not part of the graph. However, we know that the parabola is going to be symmetric about that vertical line. Okay, part D. Find any horizontal intercepts. To do that, we need to solve the equation f of x is equal to 0. So I'm going to set the quadratic function equal to 0 and solve for x. I'm going to subtract 1 from both sides. Then divide both sides by -1. Then take the square root of both sides. The square root of 1 is just 1, so now we have two equations. We have x plus 2 is equal to 1, or x plus 2 is equal to -1. To solve the equation on the left, we're going to subtract 2 from both sides. So x is equal to -1. So one of the horizontal intercepts is -1, 0. To solve the equation on the right, again, we're going to subtract 2 from both sides. So in this case, x is equal to -3. And our second horizontal intercept is -3, 0. So I'm going to go to the grid and place points at -3, 0 and -1, 0. Part E, find the vertical intercept. Recall that all parabolas have a vertical intercept, and it can be found by evaluating f of 0. So this is equal to -1 times the quantity 0 plus 2 squared plus 1, which is going to equal -3. So the vertical intercept is 0, -3. And I'm going to place a point on the grid at 0, -3. Since the parabola is symmetric about the axis of symmetry, I'm going to place another coordinate at -4, 3. And notice that the horizontal distance between each of these coordinates is both 2. And finally, State the domain and range using interval notation. Since f is a quadratic function, the domain is all real numbers. For the range, we know that the parabola opens down and the vertex is the highest point in the graph. So the range is going to be negative infinity to 1. Okay, so now that we have all of this information, we can graph the parabola. We have 5 points on there, so that should be good enough. You can go ahead and maybe evaluate a couple more points if you like. If you evaluated f of 1, you're going to get negative 8. And we can place another coordinate here at negative 5, negative 8. You could do that, however, you don't have to. 5 coordinates on a parabola are just fine. And now we're going to connect these 7 points with a smooth curve, like such. And we are done.